Hello, you're watching this Monday or Tuesday in class. Spoiler alert, I'm not there again. It's October 25th or 26th. Welcome to class. Good to see you. And thanks again to whoever's in the classroom, substitute or teacher covering for me. I appreciate you. So, let's have a look. Going into today's class period, aka this video, just letting you know, we have a test next class period. We are reviewing today with this video. This video, that is a review, will be posted. It's already posted on Canvas, so you can re-watch this experience, okay? All of your assignments will lock up the night before the test, okay? So make sure that you have everything done come test day, okay? Because they won't unlock, all right? There will be a Twitch stream Tuesday night. I will be home and I will be able to stream that night. Tuesday night before the A-day test. Wednesday night before the B-day test, I'm not so sure will happen. So, B-day folks just count on studying the night before, not right up and, you know what I mean. So, make sure to study for the test, okay? Make sure to study. We are reviewing now. I encourage you to skim a little bit when you get home, right? And then watch the Twitch stream. Study, okay? At the end of this video in class, I forgot to put it on the subnotes, so whoever's there, hi, I forgot to put it on the subnotes, but I'm telling the class now. Anywho, there is a 4.6 and 4.8 quiz posted on Canvas. This is like all our quizzes. Open notes, talk to the person next to you, feel free to use the calculator. We'll do that. Well, I hope you do that after this video. Don't do it right now because I think you should pay attention, right? So that'll be there. And then afterwards, you can just review how you see fit. So with all that info covered, let's jump into it. So I'm just going to do the review that's posted on Canvas. The problems are randomly chosen. So the problems that I'm about to do are not the same problems that you're going to get when you open the review document, okay? So I'm not just doing the review for you. I'm doing some examples for you, and then you can do some examples on your own, and then you'll have the test, okay? So the first example is division, and because this is x plus 2, I can do synthetic division. So -2 in the box, and then 2, 5. I skipped the x term, so 0, and then 4. So there's my setup for synthetic division. This is 2x cubed. So I add down. There's a 0 here at the start. 2 plus 0 is 2. And then you multiply this number by the number in the box. 2 times -2 is -4. And then you add down. 5 plus -4. Well, that's the same thing as 5 minus 4, so that's a 1. And then you take this number and multiply by the number in the box. That is -2, and then you add down. 0 plus -2 is -2, and then you multiply by the number in the box. -2 times -2 is +4, and then you add down. 4 plus 4 is 8. Every time you divide, the degree drops by 1. So this was 2x cubed, remember? So now it becomes 2x squared, and then 1x minus 2 with a remainder of 8. So how do we write this all nice and pretty? 2x squared plus x minus 2 plus the remainder 8 over the divisor, which was x plus 2. The remainder is always r over the divisor. So which answer choice is that? 2x squared plus x minus 2. Well, that one. Identify the type of function and its lead coefficient. The type of function is based on its degree. So this function is not in standard form, okay? We could write it in standard form. How about I do that? So currently we have f of x equals negative, I can't really see this color. I'm going to start over. It's a bad color. So currently we have f of x equals negative 3x squared plus 5x to the fourth minus 2x cubed plus 7x minus 8. Now, I know there's plenty of you who can do this problem in your head. I've seen you do it. But I just want to stress the fact that the degree is the largest exponent and the lead coefficient is the first, it's the first coefficient, but only if you're in standard form. So the lead coefficient is not negative 3. If you want to think of a lead coefficient as the first coefficient, the leading, then it needs to be in standard form. So the x to the fourth coming first, then the cubed, then the squared, then the x, then the constant. So my lead coefficient is 5. And my degree is fourth degree because that's the largest exponent. Now, I knew that the leading coefficient was 5 and the degree was 4 just based on looking at it from the start, right? I know that this has to come first. I don't have to literally write it out, but I'm just proving a point. And if we have a fourth degree polynomial, that means the type is quartic. X cubed, cubic, x squared, quadratic, x linear, no x at all, constant. So type, quartic, lead coefficient, 5. Solve the equation. Anytime you're solving, just plug it into Desmos and see where it crosses the x-axis because it's set equal to 0. It's set equal to 0, so I just want to know where does it cross the x-axis. It crosses the x-axis at -8. It says to type in numerical order, so that's the smallest one. And then -4, and then 0. There it is. Simple as that. Add the polynomials. What's important about adding polynomials is knowing what a like term is. You need to know what a like term is. You can only add and subtract like terms. So, 3x squared plus 5x squared is 8x squared, for example. Those are like terms because it's the same variable. The x part, the letter part, is the same. 3x cubed plus 2, let's use the same numbers, plus 5x to the fourth, guess what? These aren't like terms. They can't combine to be anything, okay? These aren't like terms. You can't combine them. So there's nothing to do. There's nothing to do. They can't be combined, all right? So like terms are when the variable is the exact same. Like terms are when the variable is the exact same. So let's go ahead and write this problem down. We've got, in parentheses, -3x to the fourth plus 6x squared minus 8 plus -2x cubed plus 8x plus 4. Okay? So, taking a look at this problem now, what do? I add my like terms together. And you want to make sure it's written in standard form, meaning the exponents go from least to greatest. So what is the largest exponent on the page? The -3x to the fourth. Are there any other x to the fourths that we can combine because they're like terms? No. Okay, then that's fine. Actually, let me use a different. Is that showing up okay for you? Yeah, that looks fine. negative 3x to the fourth. Next should be cubed. Here's cubed. Are there any other cubed terms to combine together? Not really. And by not really, I mean not at all. So just if we're adding a negative, that means we're subtracting 2x cubed. Next comes the squared. Here's 6x squared plus, is there another squared term? Regrettably, there's not. So plus 6x squared. And then here's the x term. Is there another x? No. So we're just adding a x. And then lastly, finally, here are some like terms. Negative 8 plus 4 is negative 4. So I'll just write it all nicely in one color here. Our final answer, I mean, I'm literally just going to rewrite it, but just so it's all in one color and you can read it, just in case any color is giving you a hard time with your eyeballs. There it is. Now, the nature of how this question is written, it says, just write the coefficients. So, negative 3 is A, negative 2 is B, positive 6 is C, positive 8 is D, and negative 4 is E. Oh, shoot. I wrote 6x squared. It was 6x cubed. There was another like term. Oh, shoot. So this was supposed to be 6x cubed. That's my bad. That's my bad. There is no x squared term. Oh, shoot. Let's backtrack. Let's backtrack. So, so 6x cubed plus negative 2. 6 plus negative 2 is negative 4x cubed. And there just isn't an x squared term. So let's go ahead and write 0. So it's actually negative 4x cubed plus 0x squared. That's my bad, folks. You might have been thinking that all along. I don't know. 6 plus negative 2 is 4. Positive 4. Positive 4, positive 4, positive 4. Positive 6 plus a negative 2 means 6 minus 2, which is 4. So negative 3, 4, 0, 8, and negative 4. How many zeros does the function have below if we include repeated zeros? This is lesson 4.6. That was the last lesson that I was there for, and I said the fundamental theorem of algebra. Just the degree tells you how many solutions you will have. The degree tells you how many solutions you will have. This is an 8th degree polynomial, 8th degree because that's the largest exponent. So therefore, there are 8 solutions. That's all there is to it. The largest exponent tells you the number of solutions. Is this how you factor this? True or false? Well, there were 2 factoring patterns for a difference of cubes and a sum of cubes. Difference and sum of cubes. Factoring. So there they are. Sum of cubes meant x plus y here minus xy. X cubed minus y cubed meant x minus y and then plus xy. We used a and b, but here we go. We used a and b. So those are the 2 factoring patterns. So if you take a look, if you take a look at this, This is a subtraction one, right? This is a subtraction one. Yet it has addition here and subtraction here. That's a sum, not a difference. So false. Okay. All there is to it. It's not following the pattern correctly. This is a difference, but yet it wrote plus here. A difference means minus for that first term, and then plus for both of these. So it's not following the pattern correctly. So false. F of x is a polynomial and f of 3 equals 0. What can be concluded? So if you recall, we've made this connection a few times, but let's go ahead and make it again. That if you have a function, okay, so here's a quick graph. And here's our function. It touches the x-axis here, here, and here. Those are the zeros. So I've said this many a time. How does a function work? You plug in x, and it spits out the y value. So when you plug it, let's say this is at -3, -1, and 4. Well, that means that when you plug in 4 into the function, you will get an answer of 0, which is why this point exists right there. This point exists at that particular spot because when you plug 4 into the function, you get an answer of 0. That's why that point is right there. Why is this point right there? Because when you plug in -1 into your function, you get an answer of 0. So therefore the point -1, 0 must exist. Why is this point right here? Because when you plug in -3, you get an answer of 0. That's what the zeros are. Okay? That's why they're there. So, with that being said, if f of 3 equals 0, what does that mean? 3 is a 0. That means that the graph, let's draw another graph, that means that the graph is crossing the x-axis at 3 because f of 3 equals 0. So if there's a solution at 3, what factor generates that solution? We've done this before. But like, think of the problems where it says write the function if the zeros are at -3, 2, and 1. Or -3, -2, and 1. What would you do? I hope that you would go, oh, the factors are x plus 3, x plus 2, x minus 1, and then you multiply it all together. You're exactly right if that's what you're thinking. So if there's a solution at 3, then therefore there must be a factor of -3. And with all that being said, I spoke it very slowly, but hopefully you stuck with me. That means x minus 3 is a factor. Describe the end behavior. You can either quote unquote memorize the end behavior, or you could just plot it into Desmos and observe. I'll very quickly draw it out here. It was either even and positive, and therefore the function was up, up as you went left and right. It was either even and negative, so therefore it went down, down as you went left and right. Or it was odd and looked like this and went down, up. odd positive, sorry, or it was odd negative and it went up to down. Those were the four. So let's just look at what we have. We have an odd function because the degree is odd. So that's an odd function. And the leading coefficient is positive. So odd positive is what we have there. This part refers to the degree, and this part refers to the lead coefficient. This part, this is on, it's in what, the 4.1 notes, I think. So feel free to go look at it. They draw it much prettier than I. That's the degree, and this is the lead coefficient. Odd, positive. That's what we want. So what does this say right here? It says that the function is going down on the left, which is negative infinity, and then it's going up on the right side of things, and that's when the x values are getting positive. The x values get positive to the right. So as I go to the right, the function goes up. As I go to the left, the function goes down. So whichever answer says that. Whichever answer says that. F goes down as we go left. Nope, that's down, down. F goes down as we go left. F goes up as we go right. That's what we want right there. Down to up. Down to up. Two more to go. We're approaching the 22-minute mark here. Not too shabby, Alonzo. Subtract the polynomials. So this is the same thing as the addition problem that we had a little bit ago. It's just that now we're subtracting. So let me go ahead and write that out super quickly. And honestly, let me show you just for grins, a different way to think about setting this up. Let's just think about a different way. That didn't change any of my exponents, did it? Are we all matching this time around? I don't want to make that mistake. All right, let's just think about a different way to set this up. What if we stack them? I never really thought to do that until right this moment. And by that I mean, let's, how do we usually subtract numbers like 105 minus 15? We usually stack them like that, right? And we take away, take away we do 10 minus, I'm trying to think, yeah, I don't really do subtraction that often. Written on the page, 10 minus 1 is 9, and then 5 minus 5 is 0, right? You just kind of line up the pieces, right? You with me? So what if I write this subtraction like that? So negative 5x cubed minus 3x squared. Now let's go ahead and put 0x minus or plus 9. And then now let's subtract 3x cubed plus 0x squared plus 12x minus 8. So we are subtracting this expression, and you see how I have them lined up now, kind of stacked on one another. So negative 5 minus 3 is negative 8. Let's change colors. I don't like that one. Negative 8x cubed. And then negative 3 minus 0 is negative 3x squared. And then 0 minus 12 is negative 12x. And then 9 minus negative 8, that means plus 8. So 9 minus 8 is positive 17. So maybe stacking it did a little something for you. Just showing you a slightly different way. But we end up in the same resolution here, or the same conclusion, I should say. Same conclusion. So if I go ahead and type these coefficients in to the blanks, I've got negative 8, negative 3, negative 12, and 17. Last one, evaluate g of 2, which simply means plug 2 into this function. So let me go ahead and write this function down. G of x equals negative 3x cubed plus 5x squared minus 8. And I want to find g of 2. So if we do that, that means we're plugging 2 into my function. So wherever I see an x, I'm replacing it with a 2. Oh, it interpreted my 2's as z's. Can I get it to not do that? There we go. So wherever I see x, I plugged in a 2, and I end up getting 2 cubed is 8 times negative 3 is negative 24. 2 squared is 4 times 5 is 20. Negative 24 plus 20 is negative 4 minus 8, which is negative 12. A reminder that if you do synthetic division, this was a weird random property that exists. I don't know if random is the right word, but it's kind of interesting that if you do synthetic division, I took this expression, accounted for the missing term, put the number in the box, and if I do synthetic division, let's do that one more time. Negative 3 plus 0 is, negative 3. 2 times negative 3 is negative 6. And then I add 5 plus negative 6 is negative 1. And then I multiply by the 2 in the box. 2 times negative 1 is negative 2. And then I add 0 plus negative 2 is negative 2. And then I do 2 in the box times the negative 2 and get negative 4. And then I add negative 8 and negative 4 and I get negative 12. The property that existed is that the remainder is equal to what you would get if you plugged it in. The remainder is equal to g of 2. Just an interesting thing that occurs. So if this feels difficult to you, or you feel like you make mistakes in your calculator and you're like, but I never seem to mess up synthetic division, well then here you go. You can use synthetic division, and whatever the remainder is, that is your answer. Ooh, am I squinting a lot because I'm feeling tired? It's hitting me. It's 9:07. I know that's not that late, but it's almost past Mr. Skeez's bedtime. Okay, so I just did one problem of each. The Twitch stream is for extra questions. The Twitch stream is not me going to be doing the review because guess what? This video exists. I'm not going to do it twice. I'd rather be doing anything else than this review 2 times over. Okay? So this video exists. I encourage you to rewatch it if you need me to do and if you need to see it again. But come to the Twitch stream and ask some additional questions like, get into the nitty-gritty of these, right? It's one thing for me to show you how to do the problem. It's another thing for you to do the problem and to run into an issue and then be able to ask me a very specific question. Like, Mr. Skeet, I just don't get like how you're plugging it in and getting a number. Mr. Skeet, I don't understand like why you lined it up this way. I don't know. You can ask me something more specific, but just watching me do problems, I'm sorry, it's just not going to be enough. So try, I know I'm rambling here at the end, typical skis fashion, but try the review, this review that I just did, try it out. It is posted. You will get 10 different answers from me. You will get 10 different answers from me, than me, not from me. 10 different answers than me. So try those out. It will tell you whether you're right or wrong at the end. It will tell you the right and wrong answers. So give it a shot. I am an email away. Honestly, you can see the Twitch stream like tonight or the following night, depending on when you're watching this, Tuesday night. Ask me questions and come prepared for the test on Thursday/Friday. I think I've said all I can say. Have a great rest of your day. Have a good evening. Have a good afternoon. Have a good day, sub person, whoever you are, or teacher covering me. Just want to shout you out again. Thanks for being there. And I'll just catch you all later. All right? See ya.